The Black-Scholes formula is one of the most popular financial instruments used in the past 40 years. It was derived by Fisher Black, Myron Scholes, and Robert Merton in 1973, and since then has become the primary tool for derivatives pricing. The original framework developed by the three scientists considered the pricing of a European call or put option and assumed efficient markets, absence of transaction costs, no dividend payments, and known volatility and risk-free rate. Some of these hypotheses can be relaxed to calculate an option's price in practice. So, what does the Black-Scholes formula do? It calculates the value of an option. An option, per se, is something we like. It's the freedom to choose whether to acquire a stock. The holder of the option may decide he wants to buy the stock, but he may also decide he is better off without doing it. This freedom is valuable to every investor. Hence, it has a price. Here is a diagram representing a call option's payoff. The y-axis shows the profitability of an investor who buys the call option. And on the x-axis, we have the development of the underlying share price for which the investor has an option. Upon expiration of the option, its owner will compare the strike price and the actual market price of the underlying share. If the strike price is lower than the market price, the owner of the option will exercise it. Conversely, if the strike price is higher than the market price, he won't exercise the option, because he must buy the share at a higher price than its market price. So, the profitability of the investor looks like this. At first, he buys the option, and he pays money, and his profitability becomes negative. Then, when the expiration date comes, he's able to use the option if the price of the underlying share is higher than the strike price. Even if the market price is higher than the strike price, this doesn't mean the investor will profit from the deal. He needs a price that is significantly higher to reach a break-even point and profit from the deal. The Black-Scholes formula provides an intuitive way to calculate option prices. It is beyond the scope of this course to explain how the formula is derived. The math involved can be intimidating. It'll probably take a standalone course to do that. Fortunately, many practitioners can use the formula and price options without being familiar with how it is derived, but simply understanding its ingredients and their meaning. That's what we'll do in this lesson. This is what the Black-Scholes formula for a call option looks like, and it considers the following variables. S, the stock's current market price. K, the strike price at which the option can be exercised. If we exercise the option, we can buy the stock at the strike price K. T, the option's time until expiration. R, the risk-free rate. S, standard deviation. The other symbols we see in the formula are N and D1 and D2. N stands for a cumulative normal distribution, and D1 and D2 are numbers obtained with the following formulas. If we have all inputs necessary for the calculation of D1 and D2, we shouldn't have a problem obtaining these values and applying them in the upper formula made of two components. The first one shows us how much we are going to get if the option is exercised. And the second component is the amount we must pay when exercising the option. This is the key to understanding the formula. In the first component, we are multiplying the probability of exercising the option by the amount received when the option is exercised. And in the second component, we have the discounted value of the amount we must pay to exercise the option. All this is done if the development of the stock's share price follows a normal distribution. If someone asks you to explain the Black-Scholes formula with a single sentence, you can simply say, "The Black-Scholes formula calculates the value of a call by taking the difference between the amount you get if you exercise the option minus the amount you have to pay if you exercise the option." Easy, right?